For blood test number 6 in 2025, we saw that my biological age was 17 years younger than the chronological, and if you missed that video, it'll be in the right corner. But what might be contributing to these data? So in another video, we covered supplements. But today, let's do a deep dive into diet composition. More specifically, what diet composition corresponded to blood test number 6 in 2025. So that's what we'll see here. We're going to see the average daily dietary intake from immediately after test number 5, which was on July 22nd, to the day before test number 6, which was on September 15th. So there were 56 days in between blood tests. And note that I track all of my diet using a food scale. I then enter that data into Chronometer, so these aren't estimates that you're about to see, with the full list for dietary intake shown here. So this list is ranked in terms of grams with 2 exceptions. Cheesecake, and note that that's in calories, and no, I didn't eat 24 calories of cheesecake per day. That's 1 day of cheesecake over 56 days. And then also green tea, which is in ounces. All right, so then the question that I always ask at this point in the video is, did I do any experiments for this test? As the goal is to optimize biomarker weak spots without messing up the rest of the biomarkers. So for this test, there were 3 main interventions. First, I reduced saturated fat containing foods, SFAs, and the major sources of saturated fatty acids in my diet come from coconut butter and cacao beans, and I did that to test a correlation with Cystatin C. In terms of how much I cut, for coconut butter, I cut it from 26 grams per day to about 3 grams per day, and for cacao beans from 10 grams to about 1 gram per day. All right, so let's take a look at this correlation for saturated fat or saturated fat containing foods with Cystatin C, which is what we'll see here. So also note that Cystatin C isn't just a biomarker for kidney function. It also is a significant contributor to epigenetic aging, and more specifically for GrimAge, the best epigenetic clock of epigenetic clocks for its association with risk of death for all causes. And if you missed that video, that too will be in the right corner. So we've got 3 videos in the right corner for you. All right, so when I first started tracking Cystatin C, it was in early 2024, and you can see it was close to optimal, and I'll cover what's optimal for Cystatin C in a minute. And then I basically forgot about it. I mistakenly assumed that Cystatin C was going to be a constant for all blood tests going forward, so I didn't need to measure it at every test. But as we're going to see, Cystatin C increased over the next 5 tests, as shown there. And if we look at its correlation with chronological age, and granted this is over an 18-month period, we can see that that correlation coefficient is almost perfectly linear with a correlation coefficient of 0.94, and the p-value is less than 0.05. All right, so going back to what's optimal for Cystatin C, I have a new Patreon tier dedicated specifically to what's optimal for biomarkers, which includes data for Cystatin C, but also 34 other biomarkers, more than 2 hours of video content, 52 published references, and these aren't the reference ranges, which you can get from any LLM these days. This is what may be optimal based on how each of these biomarkers changes during aging and or their associations with risk of death for all causes. So if you're interested in that, check it out. All right, so in terms of what's optimal, without going to the Patreon tier, less than 0.7 milligrams per liter is my reading of the literature in terms of what's optimal, and then avoiding its age-related increase as Cystatin C increases during aging. So for all of these tests, it was not lower than 0.7, although for that one test it was close, so we give it a red X. And then I have not avoided that age-related increase even in this relatively short period of about 18 months, which then raises the question, how can I reduce Cystatin C? So I mentioned that I've weighed all of my food since 2015 using a food scale and then entered that into a diet tracking app, Chronometer, so I can use that data to look at correlations. And more specifically, let's take a look at correlations for macro and micronutrients with Cystatin C after the July test. And that'll give us insight for why I chose to do which specific interventions to try to lower it for test number 6. So starting off with macros and micros, and I've also got body weight on this table, that's what we can see here. And note that the full correlation list is on Patreon. This is just the top of the list. It's too much data to show. So I have a specific tier on Patreon dedicated to correlations for diet with biomarkers. And if you'd like to see that, check it out. So in terms of the table, at the top, we've got the lowercase r. That's the correlation coefficient. So a positive value indicates higher levels of the nutrient or body weight is correlated with higher Cystatin C. And a negative value in that column is indicative of higher values for the micronutrient or macronutrient or body weight with lower Cystatin C. And then we've got the p-value as the measure of statistical significance. And note that I generally use p-value less than 0.05 as the threshold. This is what's defined as nominally significant. But also note that I expanded the list beyond statistical significance with p-value less than 0.05, excluding foods or nutrients that have a p-value greater than 0.05 may actually be removing some of the signal. But for now, let's take a look at some other nutrients that were on the list that had a p-value greater than 0.05 as shown there. So in going through the list, calories, lycopene, and saturated fatty acids all were positively correlated and significantly positively correlated with higher cystatin C, which would suggest, if correlation equals causation, if I reduce them, that I might see a reduction for cystatin C. And on the other hand, for whatever reason, a higher body weight, relatively higher body weight over these 6 tests was significantly correlated with lower cystatin C. All right, so what the macro and micronutrient data doesn't tell us is, for example, saturated fatty acids, but from what foods? So for now, let's take a look at correlations for foods with cystatin C. And I should mention that although I've been tracking diet since 2015, it wasn't until 2018 that I started tracking food intake. Because as we can see, the macros and micros are actually the reductionist approach relative to tracking food intake. So for anyone starting on this journey, I'd recommend tracking not just macros and micros, but also individual foods with the goal of optimizing biomarkers. So in terms of the correlations for foods with cystatin C, we can see the top portion of the list there. And once again, the full correlation list for not just this, but all diet versus biomarkers is on the correlations tier on Patreon. So in terms of what's significant, using that threshold of p-value less than 0.05, we can see that there are 4 foods. But remember, I asked about which saturated fatty acid containing foods might be contributing to the cystatin C correlation. And we don't see them in the p-value less than 0.05 box or rectangle. So we do see them though on the list. You can see that cacao beans and coconut butter each have positive correlations, but their correlations are outside of statistical significance. So if I use the p-value less than 0.05 and forgot about everything else, I would lose or miss that these 2 foods have positive correlations, albeit not significant, at least for now, but I would miss those correlations. Similarly, take a look at lycopene. Lycopene on its own has a significant positive correlation with cystatin C. But in terms of where I get the majority of my lycopene from, it's watermelon and tomatoes, which are also on this list. You can see watermelon and tomatoes both have positive correlations with cystatin C, but they too are outside of statistical significance. So if I use this rigorous threshold of p-value less than 0.05 and taking it a step further, using the false discovery rate, basically nothing on the list would be significant. I would have no actionable leads, but actually I do have actionable leads that may have made a dent on cystatin C, as we'll see in a minute. So these were the data following test number 5 in July. So for test number 6 in September, I then cut both cacao beans and coconut butter to see if correlation could indeed equal causation. So what was the impact on cystatin C? And that's what we'll see here. And jumping right into the data, we can see that reducing saturated fatty acid containing foods, in my case, lowered or is maybe a part of the story for a lower cystatin C. Now, I can't say causation. This is just 7 tests. There may be many other factors involved, but what I can say is that I followed the data and this happened to be the result. I can't say causation. This may be natural or normal variability in cystatin C data, although I should mention if there is variability in cystatin C data, only once out of the first 6 tests did I see cystatin C values that were less than 0.75. So now I see it a second time. So whether that's normal variability in the biomarker or I actually did something, I'm not sure, but I'd like to think that I did something and I caused something, but whether that's true, I'm not sure. All right, so that 0.75 is close to my best data yet when compared with that first test and better than the other 5 tests. So then what happened to the top correlations after cystatin C test number 7? So after those first 7 tests, and note that this is after blood test number 6 in 2025, so it can get a bit confusing. So note that real correlations strengthen, whereas false correlations weaken over time. And to illustrate what I mean by that, let's pull up our correlations that were following test number 5, and these are now the correlations following test number 6. So I'm going to put up the previous correlation on the left, so we don't have to jump between screens. And then starting off with saturated fatty acids, we can see that the previous correlation was 0.82, and that's now strengthened by a small amount to 0.84. So that would suggest that it's a real correlation, or it may be causatively involved. And I notice that I said may be. I didn't say that it is causatively involved, as the correlation didn't weaken. So I put an S there for strengthened. On the other hand, we can see that lycopene went from 0.089 to 0.78, so it weakened. So this would suggest that maybe lycopene is not a part of the Cystatin C story, but again, emphasis on may. To test it, I'll have to reduce my lycopene intake a bit below where it's been, and if I see a further reduction in Cystatin C, well, then the correlation will strengthen, and maybe it was a real correlation. On the other hand, take a look at calorie intake, which weakened dramatically, which went from a correlation of 0.91 to 0.63. So I give that a double W for weakened, a big weakening. So that suggests that calorie intake might not be a part of the Cystatin C story, at least over these 7 tests. And then in terms of the foods, we can see that cacao beans correlation stayed relatively strong, 0.72 up to 0.74, and coconut butter increased from 0.61 to 0.67. So again, remember, real correlations will strengthen, whereas the quote-unquote false correlations will weaken. And in terms of one of those false correlations that weakened, take a look at bananas. It went from a relatively strong negative 0.9, and in this case, close to negative 0.1 would be perfectly linear, to negative 0.68. So that's a big weakening, which suggests that banana intake, in my case, has little to do or less to do with Cystatin C relative to other foods. Now, in terms of making a further dent on Cystatin C, I'm planning on following more of these correlations, including blueberries and cinnamon. So we can see that, for whatever reason, relatively higher blueberry intake is significantly correlated with higher Cystatin C. So if I lower blueberry intake, if correlation equals causation, I should expect to see a lowering for Cystatin C going forward for the next test. On the other hand, take a look at cinnamon, which has a significant inverse correlation. So if I increase cinnamon or keep cinnamon levels relatively high, I might expect to see a reduction for Cystatin C. So those are 2 of the interventions that I've done for test number 7 coming up very shortly. So stay tuned for an update video for that to see if it worked or not. All right, so returning to the any experiments for this test question, there were 2 more. The next was the RDW, which had increased for 5 tests in a row, albeit still within the Lustgarten optimal range. Now, in terms of what I could do to potentially lower it, one of the strongest correlations in my data after test number 5, after the July test, was fructose intake. As we can see that its correlation coefficient was relatively strong. Anything greater than 0.7 is considered a strong correlation at 0.74, and the p-value was less than 0.05. So to test that, I cut fruit intake, which is where I get the majority of my fructose, to test the correlation. And more specifically, I reduced strawberry intake and I reduced blueberry intake as shown there. So then the big question is, did it work? Well, RDW did indeed move lower. After the September test, it was 12.1, whereas it was 12.3 after the July test. Now again, here too, I can't say if this is causation. This may just be natural or normal variability for the RDW. But knowing that it had increased for 5 tests in a row, and I did something, and it actually moved in the right direction, whether that's causation, I don't know, but I'd like to think that I may have had something to do with that. Now for the next test, for test number 7, for the October test, I made a further cut to fructose. So I've cut other foods that contain fructose that are helping me bring it about another 7 grams lower than where it was for this test. So will it help bring the RDW less than 12 based on the RDW's correlation with fructose? We'll have to wait about a month, or I post that data right on Patreon after it arrives, so check it out if you're interested. For the next experiment, major experiment number 3 for this test, it was HbA1c, which for 5 consecutive tests has been 5.3 to 5.4%. Now granted, that's not super high, but I've had recent values 5 and 5.1. So the goal is to keep it as low as possible, as close to 5 as possible, not 5.3 or 5.4, which is moving in the wrong direction. When considering that hemoglobin H1C is glucose bound or glycated to hemoglobin, if I can reduce my total glucose or fasting glucose, I would expect to see lower HbA1c. So with that in mind, one of the strongest correlations in my data for higher total glucose is total fat. As you can see, the correlation coefficient is 0.61, and that p-value is less than 0.05. So for this test, I cut total fat from an average of 99 to 84 grams per day over that 56-day period in between blood tests. And I already mentioned the cut from coconut butter and cacao beans, but I also made a relatively small cut to walnuts from about 10 grams to about 3 grams per day. So with fat coming down, that means something had to go up to stay eucaloric, and in that case, I increased net carbs. with the majority coming from corn, but then I also increased chickpeas and a bit of a smaller increase for oats. So what did it do to HbA1c? Unfortunately, it didn't make a dent. Stayed the same at 5.4. And I mentioned cinnamon for the Cystatin C experiment. That's also a part of the HbA1c story based on the correlations. So we'll see for test number 7 in 2025 if cinnamon makes a dent not only on HbA1c, but also on Cystatin C. All right, that's it for the experiments portion of the video. What about cheat meals? So I know that there are some in this space who stay absolutely clean all the time, all year round in terms of diet and never have a cheat meal or any junk, but unfortunately that doesn't work for me. Historically, that can lead to a binge, which is the antithesis of calorie restriction, so I'm trying to minimize that as much as possible. What works for me is immediately after blood testing, I eat some junk, whatever it might be, while sticking to the calorie goals or as close to the calorie goals for that day, and a couple days after, while also including some junk. I then get satiated on the junk, and then I return to the diet full force, having had some junk, satiated, not wanting it for another 50 or so day period, while still motivated to stay on this high nutrient dense diet. So in terms of cheat meals, immediately after blood testing, I had cheesecake, specifically the brand shown there. So that, again, that's 1 day of cheesecake and then no other cheesecake for 55 days. And on the second day after blood testing, I had the standard, which is peanut butter mixed with chocolate, so like a homemade Reese's peanut butter cup. And that was it for junk. Then 54 days, no junk, 54 days clean. In terms of junk calories, the cheesecake contributed about 1,300. The chocolate chips were about 550, for a total of about 1,900 calories from junk over this 56-day period. When divided by all of the calories consumed over this 56-day period, there was 1.5% junk, or in other words, the diet was 98.5% clean. Now, do I have to be 98.5% clean for all tests to have a 17-year younger biological age using PhenoAid? I don't know, I'm not sure, but this approach works for me. It may be different for others. I'd encourage others to find their own, how much can they cheat or how much not, before the biomarkers start to go in the wrong directions. All right, so this list is ranked in grams. What about ranking foods in terms of calories? And that's what we'll see here. This is the top 10 foods for average daily calorie intake over that 56-day period that went from test number 5 to test number 6. And note that this list is generated by Cronometer. If you want to track your own data with Cronometer, there's a discount link in the video's description. So atop the list, as it has been for many tests in the past, are strawberries. So I get the majority of my calories from strawberry intake. In terms of the why, part of that is Cystatin. The other part of that is it has a high net correlative score with biomarkers moving in the right direction versus the wrong direction, which both of those together, Cystatin and following my own correlations, suggest keeping it relatively high may be good for the biomarkers versus not. In terms of other foods that were on the list, I won't go through them all, but note that 7 of the 10 foods that are on this list were similar for this test as they were for test number 5. In terms of what came into the top 10, that was corn, green olives, and I should mention that note that my diet has no oils, even olive oil. I'm doing the experiment for including more and more olives into the diet up to a point, so I don't want to get too much sodium, but do olives make a dent on any biomarkers? So in the past, I've included very small amounts of olives, so I really can't do that or answer that question. So lately I've been adding a lot more olives into the approach, up to about 70 grams per day on average, to see how they correlate with biomarkers. So stay tuned for that evolving story over time. And then I also, or included in the top 10, was low-fat yogurt, as shown there. In terms of what left the top 10, coconut butter, avocado, and blueberries. So note that they were still in the approach, but just not in the top 10 in terms of calorie intake. All right, so that then brings us to macronutrients. So let's start off with calorie intake, which for this test, the average per day was 2,274, which is in the same ballpark of where it was for test number 5, about 2,300. In terms of protein intake, average was 113 grams per day, which is about 20% of total calories. And note that this is higher than it was for test number 5 by about 3%, which was 16.7% for test number 5. What about fat intake? That's what we'll see here. Average daily fat intake was about 84 grams per day. In terms of total calories, that's about 33% of total calories. And as I mentioned earlier, for test number 5, I averaged 99 grams per day. For this test, I purposely cut that by a bit to 84 grams to test various correlations. The majority of that fat intake did come from saturated fat, as I showed earlier with the coconut butter and cacao beans, but then also some from omega-6, as I also cut walnuts. And if you're interested in the total fat amounts for monounsaturated omega-3 and omega-6, they are also shown there. All right, next up is carb intake. And this is the carb intake that corresponds to test number 6. So total carbs are 312 grams, which seems like a lot. Note that net carbs equals total carbs minus fiber. Average daily fiber intake was 87 grams per day, and when subtracting that from total carbs, we get a net carbs of 225 grams per day. When multiplied by 4 calories per gram, we get a net carb percentage of 40% of total calories. Now note that fiber also contributes calories to the diet, as about 20% of that is soluble fiber. Soluble fiber is fermented by gut bacteria into short-chain fatty acids. In other words, short saturated fatty acids. Again, not all saturated fatty acids are the same for their metabolic effects. So in terms of the amount of calories that came from fiber and soluble fiber fermentation, Cronometer estimates that it's about 164 calories, or 7% of the total diet. So now we can generate the net macros. When considering the fiber data for 7%, we can add that to total fat. So now total fat is about 41%, net carbs 40%, and total protein about 20%. Now note that within sugars, I also track sugar intake, but not all sugars, as that's a big group. Glucose, galactose, and then it also includes disaccharides. There are just too many sugars to track. But I do track total fructose, as sucrose is half fructose, and then when adding that to total fructose, I can track total fructose intake. So for this test, it was a relatively high 57 grams per day. But, and I've mentioned this in many other videos in this series, the highest fructose intake that I've had that corresponds to any blood test since 2015 is a lot higher, more than double, 122 grams per day. So 57 grams per day is progress, albeit not perfection. And note that I did mention I'll have a further fructose cut for the next test, probably somewhere around 50 grams per day. And that will test the correlation with RDW. In terms of the test number 5 versus test number 6, we can see that I made that small fructose cut by about 5 grams per day, and that may have been the reason why RDW moved a small amount lower. All right, what about micronutrients? So let's go through the full list of vitamins, or I'm posting the full list of vitamins as shown there. And I've mentioned this in many other videos, but for anyone starting on this journey who's interested in optimizing biomarkers, I'd recommend full RDA coverage. And if you look on the list, that's true for all of the vitamins that are on the list, with the exception of choline. Choline is covered in terms of my data. It's just that Cronometer doesn't include choline data for the sardine version that I had been using, so it looks a bit lower than that RDA target of 500 milligrams per day. But then note that many micronutrients, including vitamins shown here, are much higher than the RDA. And that's because I'm following their correlations with biomarkers. And again, I have all of that data on the biomarkers tier on Patreon, so if you're interested in that, check it out. I won't go into that more in this video. What I do want to highlight are a few vitamins that are way higher than the RDA, including riboflavin, and I mentioned this in the supplements video. Riboflavin intake was 12 milligrams per day, which is higher than the RDA of about 1 milligram per day, so about 12x higher. Note that maximal absorption for riboflavin through the small intestine into the blood is about 30 milligrams per day. So I may actually go a bit higher as I'm testing the effect of riboflavin, not just on homocysteine metabolism, but it may be involved in regenerative capacity. And I'll have more on that in a future video. When that future video will come, I don't know, but I'm collecting data for it. Also note that niacin is relatively high, about 15x or 16x relative to the RDA at about 500 milligrams per day, and that's because I supplemented with nicotinamide about 500 milligrams per day for this test, for test number 6. But what I really want to highlight and focus on in this video are the carotenoids, alpha and beta carotene, beta-cryptoxanthin, lutein plus zeaxanthin, and lycopene. So the big question is, why is my carotenoid intake so high? And that's because one reason is dietary carotenoid intake is associated with a younger biological age, which is what we'll see here. So in this study, they looked at the biological age clock that I published over and over on this channel, PhenoAge. And then they looked at its association with dietary intake of total carotenes, which included alpha and beta carotene, but also beta-cryptoxanthin, lycopene, and lutein plus zeaxanthin. In terms of what was significant, we put up a red line at 1, at a PhenoAge of 1, and then where the shaded blue line is either completely above 1 or completely below 1, we have a significant association. What we can see for each of these dietary carotenoid intake variables is that relatively low levels or relatively low intakes were significantly associated with an older PhenoAge, moving in the wrong direction. And on the other hand, relatively high intakes were associated with a younger pheno-age. And I've included the amounts, the maximum amounts, that for each of these carotenoids that the range went up to. Now, there is one exception to that, beta-cryptozanthine. With beta-cryptozanthine, there's a sweet spot where going too low may be bad for pheno-age, but then you can see that although the data moves in the wrong direction at higher intakes, it just loses significance in terms of a younger biological age. So there may be a sweet spot for some beta-cryptozanthine being associated with a lower biological age relative to higher. Now, to compare this against my intake, we can see that it's in the same ballpark. And it's studies like this that are one reason why. But studies like this, for me, are just a guide. This suggests to me that having relatively high carotenoids should be a part of one's diet if the goal is to slow or minimize changes to biological age. But because I have so many blood tests, I'm able to see what my own correlations say and then come up with my own personalized data for where each of these measures should be. Now, is that actually causation? I don't know, but it may be a part of the story. All right, so in returning to the micronutrient profile, let's then go through the full list of vitamins as shown there. And again, I won't go through all of them, but I just want to highlight that sodium intake for the previous test was about 1,800 milligrams per day. We can see that it was closer to 2,500 milligrams per day for this test, for test number 6. And for test number 7, it'll be closer to 2,700 milligrams. Now, the reason I've done that, and I have a video on this, where it may be able to improve not just heart rate variability and resting heart rate, but also it may impact hair graying. But the key variable in that equation is blood pressure. So if my blood pressure goes up with a relatively higher sodium intake, while improving HRV and resting heart rate and maybe even slowing the rate of hair graying, well, I don't know if that's worth the risk. So I'm looking for the sodium intake that can potentially optimize HRV, resting heart rate, blood pressure, but also maybe the rate of hair graying. In terms of the next test, that's scheduled for October 27th, 2025. So if you want to see those data, I'll post them immediately on Patreon within a few days. Otherwise, it'll be on YouTube probably about a month after that. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I post at least twice per day in 4 other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtest.com, which is where I get the majority of my blood tests done, the clearly filtered water filter, which I use every day, at-home metabolomics, I'm up to 20 tests, oral microbiome composition, NAD testing with Genfinity, epigenetic testing with True Diagnostic, at-home blood testing with Cyfox Health, which includes GrimAge, as I mentioned in the video, green tea, drinking it every day, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, including Data is my North Star, Figuring Stuff Out is my drug, and the ConquerAging or Die Trying channel logo as shown there and that I've got on here. Link in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.